Welcome to the video to help you go through and explain a little bit about the sim here for our PhET simulator with the gravitational field and gravitational force as a non-contact force. So let's go ahead and jump into this. This is not going to be quite as specific or long as the electrical field one because a lot of the stuff is the same that I'm asking you to do in this lab, so I don't need to be quite as specific in this one. So here's the link for your let me make sure I have this going. Okay, here's the link. So you would click on that link to get you there. And then up at the top here, you have your 2 questions that we are investigating for this experiment and using the sim. Question number 1 is what happens to the gravitational force as the mass of an object increases. And then question 2 is what happens to the gravitational force as the distance from the object exerting the force increases. So in other words, you get further away from that object that is exerting the gravitational force. So what happens to the strength? So again, just like we did last time, but I had it set up for you and modeled for you. You're going to use if-then statements, and you're going to answer these questions with a prediction or what would be a hypothesis. Okay, so go ahead and pause the video if you need to, but go ahead and type in your hypothesis using the if-then statement for those 2 questions on what we're going to go through and we're going to experiment with. All right, once you're done with the 2 hypotheses here for question or part 3 of the lab, let's move through here and continue to talk about some of the other parts, okay? On the lab, okay? It's going to go through and it's going to explain what to do, and it's pretty self-explanatory. You have a distance, so if it tells you to be 5 meters apart, so right now this is at 2 meters, okay? Object 1 is at 2 meters, object 2 is at 6, so they're only 4 meters apart. So I got to move these. There we go, so that they are now 5 meters apart. Make sure that you have it set on decimal notation because I'm not, well, some of you might know scientific notation, but I'm not 100% sure everyone does, and we don't really have the time to be able to go through it. It's going to tell you in the lab what to set the mass of each of the object is. I'm not going to do that now. The biggest thing that I need to show you are these ginormous numbers that are up here, okay? And this is kind of where the issue really becomes. In fact, I want to highlight this stuff because this is super important up here. They're not going to let me. No, I guess not. Okay, so here's what's going to happen. That makes it a little bit confusing for this lab that you're going to want to make sure that you recognize. We're talking about objects that have really small masses, okay? Small in terms of the gravitational field that they produce. We're not talking about something like as big as the moon or planet Earth or the sun. We're talking about something really small, like the size or weight of a human or something like a couple of humans, and that's it. And in the realm of gravitational field, that's a really small mass, which means it's going to produce a really small gravitational force on it. And that's why we see these really small numbers. 0.0000000106785 newtons. That's really, really tiny. Okay, that's really tiny. And so, to make this easier, is that in your lab, I want you to multiply all these numbers by 1 million. Okay, and I tell you that over here, it's highlighted and I'm sorry, not highlighted, but it's italicized and underlined for you. Okay. To make the numbers easier to work with, multiply all your forces by 1 million. So you guys know that there are 6 zeros in 1 million. So that means you move the decimal 6 places. So I go 1, 2, 3, 4, 5, 6. And the number that I'm going to insert into my Google Sheet to graph is 0.106 instead of 0.000000106. All right, here's a bit of a warning. Here's where kids get mixed up all the time. You cannot, or I'm sorry, not that you cannot, because this is what happens. You need to be very careful of inputting your numbers into the Google Sheets when we multiply these numbers by 1 million, because if you accidentally have an extra 0 in there, your graphs are going to be completely off base and they're going to be wrong. And accuracy for your graphs will count for this lab. So you want to make sure that you are doing the math correctly by multiplying these numbers by 1,000,000. If you need to do it with a calculator, you do it with the calculator. The easiest way, like I just showed you, though, is you just move the decimal 6 places over to the right. Okay, but if you need to use a calculator, you can, but make sure you're inputting the numbers correctly into Google Sheets. Why are you putting it into Google Sheets? Well, because you're going to make a graph. Okay, so you go through, click the graph, make the data table in Google Sheets, click the button that's going to turn into a graph. Make sure that you have a title for the graph, that you have each of the X and Y axes labeled. Make sure that with those labels, if there's something that requires a unit like meters or newtons, that those are also on there so that you don't lose points on your graph. Okay, and then the way the graph looks will count. If you do this correctly, it's going to look a very specific way. And if it doesn't look that way, you're going to lose points for it. Okay. So that's part 5, where you're keeping one sphere constant for the object. Okay. And then you're going to do 10 different masses of the other sphere. So they stay 5 meters apart, and you're just going to keep changing the mass. Okay. And it makes that kind of funny noise if you can hear it. Ooh. Okay. All right. 6, okay, is where you keep the masses of each of those spheres the same, but now you're going to do 7 different distances. Okay, and so you're going to say that they're the same. So 100. Ooh. Oh, that's annoying. There we go. They're each 100, but now I'm going to do 7 different distances. And you're going to record that in another Google Sheet, or delete your other one. Okay, do another Google Sheet, graph it. Okay, that graph will also look very specific, and you will be graded on accuracy, not just having all the parts of the graph, but also the accuracy of the graph, because it should look a certain way. All right. Okay, number 7, there's a question for you to answer. Number 8, it wants you to go back to these questions 1 and 2, and you put an if-then statement as a hypothesis, but now what it wants you to do is to actually put in the real answer. Now that you've done the lab, what is the answer to question 1? You've done all of the data collection, you've done the experiment, you should now be able to draw a conclusion on what the answer is to those questions. So you're going to state what the answer or real answer is, as I'm saying, in quotes there, for question 1 here, for question 2 here, and then reflect on your hypothesis for 1 and 2. And what I mean by that is, were you correct or incorrect? And just tell me why. Either way, okay? You don't lose points if you have an incorrect hypothesis. Okay, you're making a prediction. There's nothing wrong for having a wrong prediction. Okay? The important part is that you know what the real answer is after you do the experiment, and you're able to reflect on your hypothesis and say, yeah, I was incorrect because I thought, this was going to increase or decrease. And it turned out to be the other way, which is fine. Just make sure that you go through and you explain it. All right? After that, there are a couple of questions, just 9, 10, 11, and 12 for you to answer. Related to what you should have learned in the lab. And that's it. Make sure you hit the turn in button when you're done. And if you have questions on it, email me or come pop into the Google Meet 1 to 2 o'clock each day this week. All right. Good luck.